How's it going?
Really good.
Sorry for the late start. I was.
What kind of schedule are you looking at? Sleeping for 12 hours. From 7 to 7. They're giving us all that time.
Yes. I don't know. The portal is back, and it's kind of a pain. What?
It seems not terrible.
It's not terrible though. I mean, it seems to like connect and it stays. But yeah, I come in, I gotta log in my phone, I gotta log in my laptop, I go over there, I gotta log in again. It's kind of, I don't know why it changed. Yeah. So I don't seem to have any control over it though. All right, so any questions? So I want to start digging deeper into some classes. You probably want to see what I'm doing now, right? So honestly, when I want Java documentation, I just go to Google, right? So I'm going to say string class, and first thing that comes up is from oracle.com, which is where we want to go. So all of the Java documentation looks like this, and when we start using IDEs, you can click a button and it will produce this kind of documentation for the classes that you're writing if you use the right kind of comments. If you put the right magic words in your comments, there's something called JavaDoc that will turn your code into this kind of documentation, which is really cool. So everything is a class in Java, right? Integers are a class, strings are a class, and so on and so forth. Strings are not arrays of characters, they're going to be an object. When we have a string equal to something, it's actually an object, it's an instance of this string class. So we talked about constructors. We made a few constructors for rectangles yesterday. Every class usually has a set of constructors. So these are the different ways we can construct a string. We can just create a string that represents an empty character sequence, right, by saying new string parentheses parentheses. We can say string and put in an array of what are called bytes, basically list an array of characters, and that will create a string. We can have a string as an argument, and that's the way we're usually going to create this, is just put things inside double quotes. That becomes a string. But there's other things we can do as well. But then there's all these methods. Once you have a string, you can do things like say, tell me what character is at some particular position in this string. So you can use the character at method. And in C, since strings are arrays of characters, we can say string bracket I, and it'll give us the character at position I. Here we would say string period character at parentheses I, give us the ith character. We can concatenate two strings, take a string, concatenate another one, which we can also do with a plus sign. We can see if two strings are equal, which is going to be useful because equal equal does not work for strings, just like it doesn't work for struct nodes, right? In C. We can do some hashing. We can get the location of a character in a string. We can say, tell me where the first space is stored, and it'll give us the index or a -1 if it doesn't find a space. We can find the length of a string with a length method. We can split a string around some particular pattern or character. So for example, if you have a string with a bunch of things separated by commas, we can say string dot split parentheses quote, comma, and we'll get back an array of things between which there were commas. So we can split a sentence into words, for example, pull off substrings, convert to upper or lowercase, and so on and so forth. And these functions, right, these methods are all a part of the string. So let's play around with this a little. So we'll forget rectangles for the moment. So there's a string. And so I'm just going to print it out with print line, and I'm going to put angle brackets around it so that we delimit it. Thank you. Alright, so that's not surprising. There's no stray new lines, there's no null terminator, none of that stuff. Okay, a string is just a sequence of characters. But let's play around with some of these functions. Alright, so we can ask for its length, and the length is just the name of the string, period, length. Right, it's just like accessing a field in the structure, except this time we're actually accessing code, which is a method. So this is fun, and there it says length is 11. So all of these things are available. So here's a string with some spaces at the beginning and the end, right, which is a fairly common situation. So there's this trim method, which tells us it'll return a copy of the string with leading and trailing white spaces omitted. Spaces, tabs, new lines, any kind of what's considered to be white space. So I'm invoking that trim method, which will give me a string that should have just this is fun, and then I'm assigning that to data. So I'm effectively trimming that string. And so there's your cleaned up string.
And it just does that from the beginning and the end?
It just cleans up from the beginning and the end, yeah.
So what if you have multiple spaces in between two words?
I don't know if there's a single method solution to that, but one thing we could do is split it at white space and then just concatenate those together. But there may be a replace also that says replace all occurrences of this string with that string. We could make that string just quote quote. And regular expressions, it's a thing, right? So there's actually a regex matcher. Right, so we can give a regular expression, the thing with the stars and the periods and the asterisks and all that kind of stuff, and we can say, does this pattern appear inside the string, and it'll tell us. There's actually a whole regular expression class in Java that will do all kinds of powerful pattern matching and substitutions.
You did replace all on a string that was, like, say, 10 spaces,
Mm-hmm.
and you said replace all space with space.
Mm-hmm.
Would the result just be 5 spaces, or would it be 1 space? Like, would it keep running it until it had replaced them all?
I don't know. Replaces each substring of the string that matches the given regular expression with the given replacement. So I think if we said replace space with, you said,
Space with space.
I think we're going to get 5 spaces, but that's a really cool question. So you can click on these and get a little more detail. But this is a perfect thing to experiment with. So let's print this out beforehand. And then let's replace that.
You might want to put something on the end of the first string so you can actually see if it's changing.
Oh, yeah. That's a good point.
Say again?
If you
You
put
put
like
string data, if you put like a period at the beginning and a period at the end, so it shows like.
so we can see how many spaces there are.
Oh, well, I got angle brackets when I'm printing it out. So we can, and I'm also printing the length.
Is your semicolon?
I'm missing a semicolon. Let's see how good the compiler is. Semicolon expected. Okay, that's pretty good. So, yep, it just replaced and then it went on. It didn't go back and recursively replace. That's cool. All right, so every time that we work with a class in this course, right, sooner rather than later, you're probably going to want to go to the documentation. And a lot of this you're not necessarily going to use, but string is part of java.lang. Okay, so like the underlying language. And we'll talk about this later, but a string is actually, it's an extension of what's called an object. And actually everything is an extension of an object. Object is like the thing that all other things are, but other things have more stuff in them also. But this gives you some examples and some wordage about using it. Tells you how to construct it and then lists all the methods. And then these are all clickable. So there's so any other questions about this? Let me show you the split, because splits are fun. All right. So split will take a string and it will take something that we want to split on. It will return a string bracket bracket. Right? We saw this on day 1 when we made our first main method. This is an array of strings. So what can we do with this? Let's say string bracket bracket pieces equals data dot split, and let's just split at the spaces. So this is saying go into the string called data. Every time that there's a space, take everything up to that, throw it into the next element of this array, which we've called pieces, and build up that array. So arrays in Java have a length. In C they don't, because arrays are just pointers. In Java, arrays have a length, and it's a field called length. So if we say pieces.length, that tells us how many elements are in this array. So we're going to do our standard for loop. I goes from 0 up to length minus 1. And let's just see what this piece looks like. Alright, it's just big long print statement. We'll say piece 5 is, and then we'll print out the value of piece 5 between angle brackets. I'm not feeling confident, but let's try and compile this. Oh, same error as before.
Pieces?
Yeah.
Lowercase pieces? New last line. The first one, pieces?
How's that look? Pieces, pieces, pieces. Okay, not bad. Alright, so you ready? So, there you go. We can do that in C. It takes a little bit of work. Right? You gotta have multiple arrays, you gotta have a pointer going through your input, pointer going through your output. When you get to space, you gotta throw on a null terminator, you gotta skip over the space, you got stateful stuff, and so on and so forth. And here it's one statement, data.split. What is data.split doing? It's doing all of that stuff, going through the input, stateful stuff, and so on and so forth. Right? And all of these things, the stuff with regexes, those are phenomenally complicated to write, really easy to use. Okay, let's do one more thing. Alright, so our string says this is a test, so we know piece of 0 should be the word this. Let's say if piece of 0 equals this, then they're equal, otherwise something is fundamentally wrong with the universe. So compile that and run it, and guess what? The universe is collapsing. Right, so this is the one, the 224 gotcha that we bump into in Java also. Equal means literally equal. Okay, quote THIS is a string, pieces bracket 0 is a string. They're not the same string. They have the same letters in them, but they're different objects. So just like trying to compare two pointers that are pointing to the same string in C, we can't just say equal. In C we use string compare. We would say string compare pieces 0, comma, quote this, right? Here, pieces 0 is a string, so it comes with an equals method. So if we can say, let me save this first. Okay, so let's instead do it like that. So piece of 0 is a string. It has an equals method. The equals method takes another string and tells you if it equals the first string. So there you go, they're equal. So I haven't said a whole lot about Java syntax. Yeah, go ahead.
Is it sensitive to application?
Absolutely. Yep. So I haven't said a whole lot about Java syntax, and I'm probably not going to, right? This looks like C, right? My for statement could be straight out of a C program. My if statement, my curly brackets are straight out of C, right? So most of the underlying mechanical syntax will be familiar to you. It's more sort of understanding how to work with these different classes, right? Doing things like string name dot equals, right? And some extra mechanics like the class keyword and public static void main and string bracket bracket and so on. But as we go through this stuff, you want to be writing code on your own. Okay, now we're going to talk about PA1 either really soon today or tomorrow at the latest. But you want to be trying these things on your own, right? Get your hands dirty as soon as possible, compiling some stuff, running some stuff. Start with hello worlds. But I'm copying all this code into the shared code area that you can get to from Canvas. And to me, a really good way to learn a programming language is to start writing code, or to take code and change it, recompile it, see what it does. Right? I'm biased. This was how I learned to program. I pulled printouts out of the garbage can and typed them in and went from there. But it gets you to explore the things that we don't have time to possibly explore, every single nuance and detail in here, right? But the ones that you stumble across are the ones that are going to be meaningful for you. So start, if you haven't already, start writing some of this stuff in a compiler, in an editor, and compiling it and running it. Okay? Don't just let PA1 be the first time that you ever say Java C, because PA1's got lots of moving pieces to it, right? Start with junk code, as it's called. All right, so there's an interesting method in strings, which is toString. So toString says this object is itself returned. So toString returns a string which is equal to the current object. So if I say data.toString, it's going to give me back data. And that's a weird thing to do. But we're going to do it anyway. Alright, so data is the string. I'm going to use a print statement, data.toString equals, and I'll print out the value of data.toString. And data.toString is exactly the same as data, right? But toString is a general method. We find it inside every single class. So any object we create of any type always has a toString method. For a string, it just returns the string, but what about other things? So let's go back to our rectangles. And I hope I still have a rectangle constructor. Apparently I do. So we're going to print out a rectangle.toString. And what is it going to give us? It's going to say data.toString equals, and it's equal to rect @ and then some weird hex number. Which is not terribly useful in itself. Let me show you something else. Let's forget about toString. let's just print out data in a print line statement. With integers and strings, we've been saying, you know, integer equals, and we just say plus sign, and we put in the name of the object, and it concatenates it, right? What's it going to do if we concatenate data, which is a rectangle, and we try to print that out? It's going to say data equals, and it's giving us the same rect at sign weird hex number. So what's going on here? Anytime in Java that we try to concatenate things together with the plus sign, we're trying to shove two strings together and turn them into one string. If one of the things is not a string, like data, which is a rectangle, the JVM will call the toString method to convert it into a string. So when you concatenate something to a string, the JVM calls the toString method, converts the thing you're concatenating into a string, and then concatenates it, because it knows how to put strings together. And the toString method for a rectangle just says, just return the word rect followed by an @ sign followed by a weird hex number, which is not very useful. But here's something really cool. We can make our own toString method, and it will override the default toString method that's already supplied for us. So here's our rectangle class from yesterday. Let's make a toString method. So this is going to be public. It's going to return a string. It's going to be called toString. It doesn't take any arguments. Okay, this matches the signature of this toString method that comes in a string class and actually comes in every other class. So this will override the default toString method. Yeah.
So are all classes you make a child of some parent class, even if you don't say they're the child of some parent class?
All classes are children of the object class.
Okay.
And the object class has a toString.
Okay.
Yeah.
Just more of a syntax question. So does Java have like the same limitations in syntax as C? So like, for instance, at the bracket, you could put it at the end of the fourth.
Say that again?
Previous line, as opposed to leaving out.
Yeah, white space is mostly ignored,
Okay.
so you can organize it however you like. All right, let's just return the string haha from our toString method. So now we're going to run this, and we're going to print out the value of data.toString, and it says data equals ha ha ha.
Do you override all functions like that, or do you have to like do virtual, like make a virtual function? You can only override virtual functions.
You can override any function.
Okay.
So what would be a more useful way to print a rectangle?
Dimensions.
Say again?
Just the dimensions.
Yeah, let's print out the dimensions. So what are the dimensions of a rectangle? Let's just say height, and then print an x, and then print out the width. So I'm doing a concatenation here, which is saying take the height, add an x, and then add the width as strings. So now when I print out my rectangle, it says data equals 5.0 by 7.0.
So can you overwrite any default functions then?
Mm-hmm.
Just by redefining it?
Just by redefining it, yeah. And whatever you define in here will take precedence over what used to be there. And that's something we're going to do a lot of. And it's a whole separate topic, the subject of class extensions. Because what we'll do is we'll say, you know, I really like the math class, but I don't like their value of pi. We can't actually do this, but so we could define our own math class. I could call it Nick Math extends math, and I could change, you know, what the square root function does or something like that. Or I could add some new functions. I could add the Sox rhythm function that my brother and I wanted to invent when we were kids. We were going to invent Soxology. It's a new branch of math. So we'll constantly do class extensions, and we'll do this a lot when we start playing around with GUIs, because there are GUIs that will do things like put a drawing area on your display, but it won't actually draw anything for you. And we can override the part that actually does the painting and get it to paint, you know, whatever we want to display. So there's more to the story than what we're doing right now, but the part that you'll need to use for PA1 is this two-string concept, right? And one thing I'll mention up front here, right, my two-string method is not actually printing anything. My two-string method is supposed to return a string. Chances are whoever is using this is using two-string inside a print statement, right? Implicitly we're calling data.toString, but that's not always the case. I might be taking the string associated with a rectangle and saving it somewhere, or hashing it, or sending it down a network connection. So usually you don't want your two-string method to actually print something, just like you don't want your square root function to print out calculating the square root of 3 now, right? It's not usually useful to whoever's calling the function. So, but we'll return a string and then let the caller decide what to do with it. All right, questions about this?
Are we gonna go over making our own methods outside? Or do you?
It's always got to be inside a class. Yeah. There really is no such thing as outside of a class, because our main method is sitting inside a class, right? And basically when I say Java space mymain, it looks for a file called mymain.class. Inside there it looks for a class named mymain, and inside that class it looks for a method named main with a public static void declaration, and then it starts executing it. But if I want to write, you know, some other function to, you know, calculate pi or something, it's going to have to be inside some class somewhere. Other questions? All right, let's take a look at PA1. So PA1, you're creating a class called fraction. And this is a class that lets us basically deal with rational numbers, fractions, as a new type of variable. So Java comes with integers, comes with floats, doubles, plus some other things like booleans and so on. But we want to be able to deal with things like 1/3, 1/3, in such a way that if we multiply it by 3, we get exactly 1 instead of 0.999999. Right? So a fraction class. So you're going to define this class. You're going to write code for class fraction. So here's the definition of the class. 2 ways to construct a fraction. The most common way is you're going to tell the constructor what the numerator and denominator are. So if you want the fraction 2/5, you'd say, you know, new fraction, parentheses 2 comma 5. It's numerator, denominator. But sometimes you want to construct a fraction where the denominator is 1. For example, the number 3 is actually the fraction 3/1. Well, I could construct it by saying new fraction 3 comma 1, but I also want a constructor that just takes a numerator and assumes the denominator is 1. So if you construct a fraction with a single argument, it creates a fraction, that argument over 1. So a pair of constructors. And then 4 primary methods for operating on fractions: add, sub, mul, and div. And so the way we would use this might be something like this. So fraction A equals new fraction 1 comma 2. So A is a half. Fraction B equals new fraction, I don't know, 2 comma 3. So B is 2/3. All right, I'm going to set x, y, and z just to be fractions, but I'm not going to construct them here. So I can do something like x equals A multiplied by B. So A is a fraction. It's going to have a multiply method. The multiply method takes a fraction n and it returns whatever the object is times n. So if I say x equals A multiplied by B, x should be equal to the value of A times the value of B, which is 2/6, which is 1/3. And so I can do arithmetic with fractions the way I do with integers or real numbers, except I have to use this kind of peculiar notion. I can't say A star B. You can in C++, but not in Java. All right, so 4 main things that you do with fractions: add them, subtract them, multiply them, and divide them. There's also a method called 2-double, which takes whatever the fraction is and converts it to a double precision floating point number. So I could do something like double q, and I could say q equals x dot 2-double. And that's going to set q equal to 0.33333. All right, and then the pair of getters, if you just want to read the numerator and denominator of a fraction, you can say get numerator or get denominator. So if x is the fraction 1/3, if I say x dot get denom, that method returns the integer 3, denominator of the fraction. And then a toString method, which makes your fraction into a string that looks like a fraction. So number slash number. Which means if I were to say print x equals, and then concatenate x to it, this should print out x equals, and then it'll call the toString method on x, which is a fraction equal to 1/3, and that should return the string 1/3. So when you get this all wired up, it's like fractions are now a valid data type. You can declare them, you can initialize them, you can multiply and add and subtract and so on. You can print them, and if you get tired of them, you can turn them back into regular double precision numbers and do your thing with them. So those are the public methods that whoever's using your fraction package should have access to. And let me give you an idea of some of the things you can do. Well, actually, I have examples in here. I have some test code for you. So this is not part of what you're going to turn in, but I suggest trying these tests on your class as well as other tests. But for example, A is a fraction equal to 1/2, B is a fraction equal to 4, C, D, and E are fractions. I can print out a new fraction 125, 50, and that should give me the value 5/2. So fractions should always be in lowest common form. Okay, so find the greatest common factor and divide by it. So there's Euclid's algorithm coming back to help you. But you can do things like this. I can say I want a new fraction 1, 2, which is 1/2, and that new fraction will have a multiply method, and I want to multiply by a new fraction which is just equal to 2. And the result of all of this should be a fraction just equal to 1. And now I'm saying call the toString method and concatenate it to the string, and so this whole thing should print out 1: space and then just the number 1. And so you can nest these things however you like. Here's my new fraction 1/3, and I'm calling the toDouble method. And if you get crazy, it will probably play along with you nicely. So I can say like new fraction 2, 3, and I want to add to that the fraction 4/7, and that's going to be a fraction. So if that's a fraction, it's got a bunch of methods to it. I could have a method dot multiply, and so on and so forth. It's not the prettiest way to write it. It's nicer to just have plus and star, but this is a fraction, right? It's an object. So anything that we can do with a fraction, we can do with this. So we can call mul or toDouble or toString or whatever. Okay, so does basic description make sense? So how do you start this? You can start with the rectangle class. That gives you like a framework for how to define a class. But a rectangle is a thing with a height and a width. A fraction is a thing with a numerator and a denominator. And make some constructors. And I don't know, try the multiply function. Multiply is easier than add, actually. And start putting some of these things together, but keep writing test code, keep writing a main program that uses the fraction class as you're developing it.
So, would you also think that you have to make some way of reducing it?
Yes, so there's a lot more detail here that we'll probably get to tomorrow, but this gives you enough to start in on this. But the details are, we've got to deal with division by 0, okay, which I have specific requirements for. You've got to be able to reduce fractions, which means you need to find a greatest common factor, which means you need to code up Euclid's algorithm. Okay, but you've done Euclid's algorithm in 215. We'll review it in here tomorrow, but it's a basic while loop. And you just keep track of the two numbers, you reduce, you change your two numbers, and you keep going until one of them is 0. And then the other one is your GCD. But you got to deal with negative numbers when you do that. And you also need to deal with negatives in your fractions, because if you create a fraction which is -2 over -3, and I ask you to convert that to a string, you don't want to print this, right? You'd really like to print this. So we need to be a little careful with how we deal with negatives also. And then division by 0, as I said, is another issue. So we'll go through those details tomorrow in the grading rubric as well. But that's the high-level view of it, so that should get you going on it. All right, so I'll see you tomorrow.